I'm going to leave my camera off if you don't mind. Tends to
Yeah,
overheat, turn it to overheat my chip. Let's see, we want this one, the upper left, right?
yes.
And then we want homework as soon as it comes up. Chapter 13 homework?
Yes.
Okay. Question 1?
Yep.
Okay. And let me know if I'm not in the window that you're seeing.
Yeah, you're fine.
Try to center everything about the middle. Okay, let's see. Original size. Oh, it was already expanded, huh? Can you read that okay?
Yeah, I should be alright.
Okay. Find the open intervals where the function graph is increasing or decreasing. Okay. What's the interval where it's increasing?
I want to say from negative infinity to the point, but the arrow says otherwise.
Well, not really. If you look here, you're correct on the negative infinity and the point. In other words, it's increasing this whole way from negative infinity up to minus 2. They're talking about the x coordinate when they're talking about the interval notation. So we need left paren. Can I use the paren in my keyboard?
Yeah.
Negative infinity. Is that on your end or mine?
Yeah, it's my oven going off, sorry.
Oh, good. Otherwise, it was my smoke alarm, which wouldn't have been good. And do we want a paren or a bracket here?
Looks like a bracket.
Actually, a parentheses.
Okay.
Because it's not really increasing at that point right there. It's only increasing up to that point. And what's the interval that's decreasing?
Negative 2 to infinity.
And then, of course, infinity always has a parentheses, never a bracket. Number 2, right?
Yep.
Suppose that the graph below is the graph of f prime of x, the derivative of f of x. Find the open intervals where f of x, the original function, not this one, but the original, is increasing. Let me show you something that may be useful to you. I usually show it to most of my calculus students if I can figure out where I put it. Have I showed this to you before?
I don't believe so.
Here we have the function. Here we have the first derivative, and here we have the second derivative. Now, the most important relationship you can make between the function and the first derivative is when the function is increasing, the first derivative is positive. When the function is decreasing, the first derivative is negative. Notice how we're increasing from this point to that point, and we're above the x-axis in the first derivative, so we're positive. Then the moment it turns and starts decreasing, the whole time it's decreasing, we're below the x-axis on the first derivative. And then when it turns around and starts increasing again, we're positive. So that's a key relationship between functions and first derivatives. So let's look at this thing again. So if we want the open interval where the original function is increasing, we want to know where this thing is positive. What interval?
That would be negative infinity to...
No. We want only where this thing is positive. Where is this positive? And by positive, I mean the y thing. The y measurement has to be positive.
So from 1 to 5?
Correct. In other words, in that interval, this is positive. That means the original function is increasing. What interval or intervals is it decreasing?
Negative infinity to 1 and 5 to infinity.
Do I have a union sign somewhere over here, or what? How do I separate those?
I think you could just use a capital U on your keyboard.
Okay. Uh, 5, comma, positive infinity. Well, must not be able to use that. Over here on the left, which one is the in union with?
You can click more, see what comes up.
Yeah.
There it is.
It's this one here, right? Yeah.
Yep.
Okay. Do I have that right? Negative infinity to 1, parentheses, and then 5 to infinity, that's where it's negative.
Is it brackets for 5
No.
and 1?
No. List any intervals on which the function is decreasing. Because see, at 1, it's neither decreasing nor increasing. It's flat. The original function is flat. That represents a peak. All right, am I reading this wrong, which is why I kept making those other mistakes? I want to know where it's decreasing. When we type that in, it says use a comma to separate answers. Is it possible we need to use a comma in place of this U?
Yeah, it could be.
Gosh.
That's a joke.
That is. It's the one problem with these internet stuff. They don't have enough of a human element to them to recognize that you had the right answer. The critical numbers. Okay. Critical numbers are what value of x makes f of x 0. Or division by 0, but in this case,
So could it just be 0?
Well, we want to solve this quadratic, letting f of x equal 0. Do you have a calculator that'll do that?
I don't think my calculator does, or I don't know how.
Wow, because my calculator isn't working. This is not a particular easy quadratic to solve, or is it? What's 0.7 of that?
Or maybe Wolfram Alpha.
Ah, there you go. Thank you. Gosh, what was I thinking? Or what was I not thinking? Let me copy and paste here. I bet it does.
I don't think so.
No. So it's minus 0.7x squared plus 2.4x plus 2.7. Minus 0.7x squared plus 2.4x plus 2.7. Well, those two solutions look like, let's see, x is, why do I have a feeling that when we type these in, it's not going to like that? How many decimal points should we put?
I don't know. It doesn't say. Maybe like 2 or 3.
Okay. First of all, let's look at this thing before we do that. We can tell that the function is going to be increasing from negative infinity to that point. So let's write that thing down also, or let's take note of it. I guess that has to be halfway between these two numbers. Be surprised if they didn't tell us what it was. They don't, though. Okay. Well, let's start with these two numbers. So I'll try minus 0.893 for one of them. And the other one is 4.321. 4.321. We got to take the derivative of this. Excuse me. What was I thinking? If this is the function, and this is what the function looks like, we want to take the derivative of this, which gives us that point after we set it equal to 0, and the answer will be whatever the x value is for that. So let's see. we don't want this function. We want negative 1.4x plus 2.4. And we want to set that equal to 0.
How'd you get the 1.4?
How'd you get the 1.4 again?
I took the derivative of the function by using the power rule. In other words, here, let's...
Oh yeah, you just do 0.7 times 2, right?
Right. So you get negative, and then you subtract 1 from the exponent. And then for the second term, you just take the coefficient of the x value. And we want this to be 0, so it's whatever that x-intercept is. So it looks like 1.714. Let's try that. 1.714. Minus 1.4x plus 2.4 is the derivative. That is f prime of x. In other words, f prime of x equals minus 1.4x plus 2.4. And they want to find out what x makes this whole thing equal to 0. So if I solve this equation, I get x equals negative 2.4 divided by 1.4. I can do that on my calculator. 2.4 divided by 1.4. 1.714. And there's only one of them. You'll notice that the derivative is linear. This is what the derivative looks like.
Yeah.
So there's only going to be 1 0. So I'm not quite sure what's going on here.
Maybe just do 1.7.
Okay. Are you kidding me? Wow.
Fraction.
Well, because it was an irrational, or it was a repeating decimal. Actually, I don't see any repetition in it. So maybe it's an irrational number. Well, it's not an irrational number, but it's a number that can be represented by a fraction exactly, whereas it can't be represented. Notice that I got negative 2.4 over 1.4. That reduces to 12 sevenths. And 12 sevenths is perfectly 100% accurate, whereas when I tried to put it in as a decimal, the best I could do is round it off. So I kind of understand why they want it as a decimal. I just didn't know that to begin with. So let's see, can we do a similar one? Or not yet, huh?
Yeah, not yet.
Okay. So list any interval on which the function is increasing. Well, if the function is increasing, what's the derivative doing?
Decreasing.
No, it's positive.
Oh, it's positive.
If the function is decreasing, the derivative is negative. So we're looking at the derivative curve here. So the derivative curve is positive from negative infinity to 12/7. Ah. Oh, I love it.
You have to decimal. Yeah, the parenthesis.
Wow. How do I do that again?
Just do your keypad. Just move one over.
12 divided by 7. Oh, and then go to the right. Okay.
Yeah.
And that's where it's increasing. In other words, don't get confused by the fact that the derivative is heading down. The derivative is decreasing, but the derivative, the only thing we're looking for is where it's positive and where it's negative. Where it's positive, the original function must be increasing, and where it's negative, the original function must be decreasing. So, where is it? Decreasing from
12/7 to infinity.
12/7. Now, can we do anything to do a similar problem? Because they're really kind of easy to do. Once you figure out how to take the derivative and solve it, set it equal to 0, you want to come back?
Yeah, if you just do similar exercise, it's fine.
Okay, should we do that now or do it later?
We can do it later.
Okay. Or you can even do that on your own, maybe. Okay.
Yeah,
for the following function, find the critical numbers. Same thing.
Would it just be, well, the derivative, would it be -4?
Correct. Means the original function is doing what?
The original function is decreasing.
Throughout its whole domain. In fact, we can tell that by looking at it. It's got a slope of -4. So we know the original function is a straight line going like that. So setting that, we don't set it equal to 0. Hold on a moment.
Would the critical number just be 12/4? Or 3?
No, that would be taking this function and solving for x, which is the mistake I made on the last problem. In other words, the last problem, to find the critical number, you took the derivative of the function and found what value of x made that thing 0. Well, no value of x makes the derivative 0. So
You'll probably get 2 or 3 chances if you put there are no critical numbers.
I don't think there are. Okay, let's try that. Yeah, I didn't see that option yet, but okay. That would have made it easier. I was getting frustrated trying to figure out how to answer it. Okay, identify the open intervals where the function is increasing.
There are none.
Okay. And the interval where it is decreasing
would be negative infinity to infinity.
Yep. Number 5. Okay, what's the derivative of f of x? What's f prime of x?
So whichever one's bigger, 18/19ths, or no, 37/19. Negative whatever 37 divided by 19 is.
Well, let's leave it as a fraction since we know that they like that better. And then when I subtract 1 from this numerator, which is subtracting 19/19ths, I get 18/19ths. So that's the derivative of that term, plus the derivative of this term, which is 18/19ths x to the minus 1/19th.
Could you explain that again?
Yeah, the power rule basically is if f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. So you start by multiplying the coefficient by n. So I started with this term here because it had the largest exponent. So it's minus 37/19ths x, and then when I subtract 1 from that, I'm left with 18/19ths. And then when I do this term, and I don't have to do them right to left. I could have started with the term on the left first. It's not necessarily that they be in order of the highest exponent, but if you apply the same power rule to this, it's going to be 18/19 times x to this minus 1. And when you subtract 1 from that, you get minus 1/19. So that's what f prime of x is equal to. And to find the critical numbers, we want to know where this might be equal to 0. Well, let's rewrite this so it's a little more intelligible. In the numerator, I've got minus 37/19ths x 18/19ths. Since I'm going to set that equal to 0, I'm going to move this other term to the other side. So it will be minus 18/19ths x to the minus 1/19th. In other words, when I set f prime of x equal to 0, then I get this expression equals that expression. Here, let me setting that equal to 0, which is always what you do in calculus. So there's the equal sign. Now, the term on the left, let's rewrite it with a positive exponent because it's significant. Minus 18/19 x to the 1/19th. All has to be equal. to minus 37 over 19x to the 18/19ths. So now how do I solve for x?
I have no idea.
Well, if I multiply both sides by x to the 1/19th, I multiply this side by x to the 1/19th, a nice thing happens. Everything crosses over here. This becomes x to the 1. So I end up with minus 18 over 19 equals minus 37 over 19x. So x is equal to 19 over 37 times that. Follow me on that? And then the 19ths cancel, the negative signs cancel, and you end up with x equaling 18 over 37. Now, there's actually another critical point besides 18/37ths, and that is x equals 0. Because on this original left side of the equation, notice that I had x in the denominator. So x cannot be equal to 0. So let's try 0, comma, 18 divided by 37.
I don't think you need the parentheses.
Because it's not an interval notation. Tell you what, I wouldn't do very good on these things. I make a lot of mistakes, but they're the kind of mistakes that are screwy. Okay, the intervals where the function is increasing
I don't know. I'd have to see a graph.
Well, let's figure out whether I can pull it up on Wolfram Alpha easy enough, but for the original function to be increasing, the first derivative has to be positive. It has to be greater than 0. Well, we just figured out that at x equal 18/37ths, the first derivative is equal to 0. So on either the right or left of that number, let's just graph it. Okay, that's the function. which means it's increasing from negative infinity to 0. Excuse me. It's increasing from negative infinity to 18/37. That point right there is going to be 18/37. And then from 18/37 to positive infinity, it's decreasing.
Would it be to 0 and then from
Well,
1837?
Because it's undefined at 0. This one doesn't show that, but in fact, can it be negative? Can the original function be negative? According to this, it can be. In other words, blue represents the real part, and the imaginary part is this color orange here. But according to this, the original function is increasing from negative infinity to this value right there, which is 18/37. And then it's decreasing from that down. Remember, this is the original function, not the derivative of the function. I could type the derivative of the function, which we can just look where it's positive and where it's negative, but that's going to be the same thing. I'm quite certain. Let me try it anyway. Let's see, we want negative 37 divided by 19 times x raised to the 18/19th power minus 18/19ths x raised to the, what was it, negative 1/19th? Yeah, negative 1/19th power. I got everything right there. X raised to the 18/19ths minus 18/19ths x raised to the, okay. Okay, so this shows the derivative All right, you were absolutely correct. We need to go from negative infinity to 0. Do I have a sign wrong here?
I don't know. That's a weird looking graph.
Well, what's weird about it is it doesn't match our 0 for the function. In other words, when we solved for x, the 0, or the, not the 0, the 0 of the derivative, we came up with 18/37. That was correct, wasn't it? Yeah.
Yeah.
Okay, let's try this here. Let's go to 0 combined with, let's try this. This should work. 0 to 18/37. That look right?
Yeah.
That's where it's positive. So that's where it's increasing. If, according to this, I must have done something wrong when I took the derivative of the original function. It's 18/19 x to the minus 1/19 minus this. I did do something wrong. No, I didn't. No, I didn't. This is what I got right here, which is 18/19 x to the minus 1/19 minus 37/19 x to the 18/19. So that's f prime. It's not defined at 0. It's equal to 0 when x is 18/37. And if we look at the function, it's clearly increasing. And okay, it's not defined at 0, but then it's clearly increasing all the way up to that value right there, which is 18/37. And then from 18/37 to infinity, it's decreasing. I'm not sure what's going on here, Sean.
I'm not sure either.
Should we hit a final check or come back to it?
Yeah. You hit a final check and then I'll tell you the right answer.
They're saying it's not defined when x is negative. But that's not true. Because I'm taking the 19th root of x, I can take odd power roots of negative numbers. In other words, when I write x to the minus 1/19, x can be positive or negative. That's why Wolfram Alpha showed it the way it did. It showed it in the negative. It can be negative. It's not listing that as imaginary, although it does list that as imaginary. Huh. All right. All right. I'm not sure why it can't be negative, but okay, so the intervals where it's decreasing is going to be 18/37 to infinity.
think it's the function is never decreasing.
Well, here's the function. It's decreasing. You can see it. There's its peak, and it's decreasing everywhere after that. And according to this, it's decreasing out to infinity. I don't know what to do here. I guess a final check. Let's see what they say. Wow, really? Minus infinity to 0, comma, when we plotted that second function, it's got it decreasing. This is the derivative function, and it's decreasing from negative infinity to 0, and then again from 0 to infinity. This is very confusing. I feel like I've typed in a mistake here or something. Oh yeah, this was supposed to be plus. Yeah, I did make a mistake with this curve here. So this is the derivative function, and we want to know wherever this is positive, it's decreasing. Wherever it's negative, it's increasing. Well, it's positive from negative infinity to 0, and then from 0 to 18/37, and it's negative from 18/37 to infinity. I'm stumped. Let's go on to another one. I don't understand their answer. It doesn't jive with my graph either. So we have a cost and a revenue function. Well, the profit is the revenue minus the cost, right?
Mm-hmm.
So we want to take R of x minus C of x and figure out where that's increasing. So we take the derivative of that and figure out where is that positive. All right, let's go through that process. Although we don't have very much good luck when we have to come up with odd answers or decimal answers. Okay, so revenue minus cost. You can see why that's profit.
Mm-hmm.
Oh, you got to be kidding me. And then they're going to throw in all these decimals? What is their purpose here other than torture?
Torture?
I mean, that's crazy, isn't it? So we got 0.432. So P of X is equal to 0.432x squared. And let's see. Here we got 0.0002, and we're subtracting 0.00012. So we got 0.00008. And that is a positive number. X cubed. So there's our profit function. Well, okay. I'm trying to think of the best way for us to do this. Are you allowed to use a graphing calculator to solve these?
Yeah, I believe so.
Okay. Well, probably the easiest thing for us to do then is to stick this into Wolfram Alpha and read the X values off for where it's increasing. Let's try that. And we don't want to take the derivative of this because this is the profit function. So this is 0.12348x cubed plus 0.432x squared. Okay. Unfortunately, we need that value right there. So we want from negative infinity to here combined with 0 to positive infinity. Well, how do we figure out that? Well, if I put in the first derivative and set it equal to 0, that'll be this value right here. It's approximately minus 3,000 and change. But let's do that. Let's figure the first derivative. So we have 0.864x plus 0.00024x squared. So we know that it's increasing up to the negative value, it's decreasing from that value to 0, and then it's increasing again from 0 up to the positive value. So let's remember that. Let's see. Okay, so that value right there, it was increasing from negative infinity up to there. And what is that value? It's one of the zeros, minus 3,600. Okay. So the profit function is increasing on negative infinity. They take away the infinity if you don't use it. To minus 3,600, comma, 0 comma, positive infinity. Does that look right?
Yeah.
What, you a betting man? Oh, come on. Here's the profit function. This is cost minus, or this is revenue minus cost. Precisely. And it's increasing from negative infinity to 3,600, and again from 0 to positive infinity. And it's decreasing from negative 3,600 to 0. And that's what we put. Sean, I don't know what's going on here. I never had a test. I take calculus tests online. I do better than I do on this thing.
Yeah, this website's not
This is very weird. Well, plus they make you spend so much time doing complex arithmetic, like making this the 3 decimal points and this the 2 decimal points. I mean, that's just torture. And then
Click
they did.
help me solve this button on the right. It takes you through it, and you can see what they want you to answer.
Okay. So we got this. There was the profit function. Now find p prime of x. Okay, we did that. Am I supposed to type in there?
Yeah, they want you to plug it in.
Ah, got the wrong sign. Did I do that over here? Oh, I did do it over here. Why is it negative? Oh.
So if you close out right away, I don't think it'll change the problem, because if you keep going, it changes the problem.
Okay. Just trying to figure out. They've got the revenue function minus the cost function. There's the revenue function minus the cost function. Yeah, I didn't do my subtraction right. Wow, I didn't subtract polynomials correctly. Okay, so I should close this out?
Yeah, just hit close.
This x here?
Yep.
Okay. So the derivative was minus.
So I think they did change it. Those different numbers. Yeah.
So let's go back and plot that on Wolfram Alpha.
Well, David, I think they changed the question.
Oh, okay. We can't fix it then, huh? Oh, they changed all the numbers. Okay, so let's do this one. So I've got 0.778 x squared minus 0.0002 x cubed minus 0.13 x squared. Oh, I can't believe I did that. So in this case, this one is what? 0.648 x squared. Then I have to add these two numbers. So that becomes 0.00028 x cubed. So now my first derivative is 1.296x plus 0.00084x squared. Okay. Let's put in the original, the profit function, 0.648 x squared plus 0.00028 x raised to the third. It wasn't doing anything. I was doing all of that typing. Why not? All of these numbers make it much slower to go through these. Okay, so this has the same shape, only we're looking for that point, and 0 is going to be the same point over here. So to find that point right there, we're going to list the derivative and look for its 0. So the derivative is 1.296x plus 0.00084 x squared. So it's positive from negative infinity to, are you kidding me? They make the root that? Minus 1542.86? Really? Minus 1542.86 is this point right here, which means that is the first point that it stops increasing. All right, let's see if we can get this one. Why did we miss it last time?
Because we had positive in the derivative.
Oh, that's right, because I did the algebra wrong. Yeah. So this should be correct, right? In other words, based on this picture, hold on. Here's the profit function. It's increasing up to that point, which is minus 1542.86. And then again from 0 to infinity. Any suggestions?
I have no idea.
This is not the way to learn calculus. Really isn't. The fact that they've computerized this makes it just incredibly slow. You know? How do they get their x cubed? Oh, they got a negative here, and they're adding this. I did that math wrong. In other words, I keep making math errors here, despite trying really hard. What's the best way to back up here? Can I do it?
If you hit close, I don't know if it'll still be the same problem. Nope.
It's different. But now I know what I did wrong. All right, let's get through this problem, at least tonight. All right, let's see. They're making success or failure be so dependent on your arithmetic. You know what I'm saying?
Yeah.
Okay, so we got the revenue minus cost. Okay, the revenue function is 0.9366x squared minus 0.0002x cubed. And the cost function is 0.12x squared minus 0.00004. So let's see if we can get the profit function correct this time. Profit function. If I subtract these, I get 826. No, I don't. I get 816. Plus, they make it extremely easy to make mistakes, giving you 1 to 3 places and the other to 2 places. I think I subtracted that correctly, though. Okay, and to get the second part of this, I'm going to add this to this negative number. So what do I have? I have a minus 0.0002, and I'm going to add a 0.0004. So that makes this minus that. And it is a negative. That should be our profit function. So let's take the derivative. 1.632 minus 3 times 16 is 48. X squared. So there's our derivative function. We want to plug the derivative function into Wolfram alpha so that it'll tell us the 0 points of this function. There's a problem. You see what it is?
No.
Doesn't match the function. In other words, the derivative function is telling us that the original function had a flat spot there and had a flat spot there at over 3,000 units. And yet the original function, that wasn't it though. Let me put the correct original function. Maybe it is correct. And possibly, because this is a minus, it's 0.16. So this is the profit function right here. Huh? Okay. So the profit function is increasing from 0 to whatever that value was that represented the 0. So it's increasing. This looks like the profit function is increasing from 0 to whatever this value is here. No, excuse me. I want to go the other way. I got to rewrite this. $1.632x minus this is our derivative function. So according to our derivative function, we are increasing from 0 to whatever this number is, and that number is 3,400. So we're increasing from 0 to 3,400. We almost certainly that has to be right. I'm confident. 0 to 3,400. That it?
Yep.
Okay. We want to keep going? How long are we going to go tonight?
Well, for the hour and a half, we have like
okay, so we
10
got
minutes left.
we got 15 minutes. We started at like 6:15. Okay, so let's go to 7. Well, let's plot the function. Point 0.0001, no, see, I made a mistake already. 0.001 x raised to the third minus 0.01 x squared plus 0.02 x plus 0.03. Let's see, does that look right? Yeah.
Yeah.
Okay, so that's our function. And they want to know on the time interval 0 to 5, when is it increasing? From here to there, right? You can see that? Okay, so how do we find this point here? Take the first derivative, and that'll be 0 on the first derivative. Notice that this local maximum here always has the slope of the tangent line as 0. So if we take the first derivative of this function and set it equal to 0, that's going to tell us that x point right there. In fact, let me open up another Wolfram alpha so that I can leave this one up. What's the first derivative going to be? 0.003 x squared minus 0.02 x plus 0.02. This is the first derivative function. So this point right there, if we pull up the other function, in other words, there's some point right there less than 1 where it stops increasing. That point is 1.22. How can that be 1.22? That point right there. There's 1. Wow, their graph is amazingly inaccurate. You see the problem here? They're telling us the roots of this is 1.22 and 5.44. Well, I believe the 5.44. That looks like 5.44, but there's no way that's 1.22. All right, let's go with it. 1.225. So it's increasing from 0 to 1.225. $1.225. And also, it's increasing from that point forward, but they specified that the function only applies from 0 to 5. So there's no other time that it's increasing. The problem is when we get it wrong and we look at their answer, we've always done it exactly that way. You see that?
Yeah.
Now, well, clearly we can't go left of 0. Oh, it's got a bracket. No, that doesn't. It's not increasing at 0, at times 0. That can't be a bracket. That's got to be a parenthesis. Makes me think that this number they're giving me here is not the right number. It doesn't look to be the right number even. What is that x value right there? According to this, does this graph make sense? This graph right here? This is the function in operation. How can the alcohol level decrease from this time to that time?
I don't know.
If you drink 8 ounces of hard liquor, this graph would indicate that your blood alcohol level drops from that time to about 5 seconds. Or 5 whatever, minutes, hours, I guess, 5 hours. Is that exact function? It is. So as difficult as it is for us to believe that. Now see here, if I put the cursor on that flat spot, that looks like 1.22.
Mm-hmm.
And that looks like 5 point something. So it should be increasing from 0 to 1.22 and then decreasing from 1.22 to 5.4 whatever and then increasing again. But it only applies from 0 to 5, so we're not going to go past 5. Nearest hundredth. So I hate it when we waste 15 minutes
Yeah.
and we miss it because of something like that. That's just not right. I don't mean wasting 15 minutes, but all right, so let's see. Determine when the blood alcohol is decreasing. Select the correct choice. Okay, it's going to be decreasing from 1.23, comma, what's the right-hand number should be?
Infinity?
No, if we look at that
No.
chart, it's somewhere there. And if we look at the derivative chart,
Is it 5.7?
yeah, it's over 5, but this function only applies up to 5, so we got to stop at 5. It's supposed to be 5.44. But for this, we better not put 5.44 there because it's got to stop at 5. Now the only question is, do we use a bracket?
I would try the bracket first, and then if that doesn't work, would it be never decreasing? Because it doesn't.
No, it clearly is decreasing. If we look at this chart, look, it's decreasing right here. From there to there, it's decreasing. This is the function. The question is that it says this function only applies on the interval 0 to 5. So there's no way we can go beyond 5, but at 5, it's still decreasing. So I think we need a bracket, not a parentheses. Let's try this. It's not in correct format. All right, let's try parentheses. Okay. Should we look at another one, or are you ready to stop?
Well, if the hour and a half is up. Then,
Yeah, let's stop. These are. This is odd. This is very bizarre. I've had hard calculus sessions before, but it's because the calculus was hard. This is not that.
Yeah.
This calculus is not hard at all. In fact, if we had multiple choice answers, we would have breezed through this in 30 minutes instead of an hour and a half. It's getting their answers in the right format that is brutal. Okay.
And then instead of Thursday, do you have tomorrow open?
I
and
do.
Perhaps earlier than 6?
I do.
Like 5 is the
I have
earliest I could get.
Okay, let's set it at 5. Let's see, that's July 3rd. And again for an hour and a half, I presume.
Yes.
Yes.
Okay. I don't know what to say.
It's rough. It's okay.
That was brutal. And this is the way you have to do all of this all the time. Wow. There's something wrong here. I haven't quite figured out what it is, but there's something wrong with this method they're using. It's not it's not working to your best advantage for learning calculus. At least I don't believe it is.
And I have to
They
do
could,
it for
they,
the
could,
test.
they could teach the calculus principle just as easy if they made this x cubed and this 0.1x squared. In other words, I guess they're trying to be too real. This is a real function probably that really does represent the blood alcohol concentration. Huh. Nice to know that it decreases from hour 1.5 to hour 5. Yeah, I believe that. Try telling that to the cop that stops you.
Yeah.
So that makes me believe that they're making up this function and it's not really real. And if they're doing that, why are they making all of these decimals? I mean, is it really necessary to do that? Wow.
No.
Yeah. All right, Sean, I will talk to you tomorrow night at 5.
All right. Thank you.
Okay. Talk to you later. I'll close out of your
Bye.
program here also.